Through the 1930s and the early 1940s, the Navy divided carrier-based bombers into two classes, torpedo bombers and dive bombers, each with a crew of 2 or 3. This generally consisted of a pilot, gunner, and navigator. During the early conflict in the Pacific Theater, it was revealed that pilots could deploy the armament accurately without the need for assistance, while navigation could be aided by the use of radio beacons. The introduction of more powerful engines resulted in an increase at top speed, negating the need for a defensive gunner. As such, the 3-crew layout was largely unnecessary. On top of this, the Navy also realized they needed a larger fighter fleet to defend the strike force from enemy aircraft. Due to the limited space available on a carrier, an increase in fighter count would reduce the available space for specialized torpedo bombers and dive bombers. To solve the issue, the Navy introduced a new class of aircraft. The BT, or Bomber Torpedo Class, would be a multi-role aircraft capable of fulfilling the roles of torpedo bombers, dive bombers, and scout bombers, all in a single airframe. In January 1942, the Bureau of Aeronautics issued its first specification for a BT aircraft to replace its fleet of quickly aging scout bombers. The specification required a single-seat design powered by the then-in-development Wright R3350 duplex cyclone radial engine. In terms of payload, the specification called for an internal bomb bay with space for 2 1,000-pound bombs, 2 1,600-pound armor-piercing bombs, or a Mark 13 torpedo hung below the fuselage. Curtiss would be the first to respond to the request, with their Columbus division submitting the Model 96 a mere 6 months later. Along with the required R3350 design, Curtiss also proposed an unprompted model powered by the new Pratt & Whitney XR4360 Major Wasp engine. Later that month, Curtiss received a contract to produce 2 of each proposal, designated XBTC-1 and XBTC-2 respectively. The choice to include a design with an alternate power plant later proved a wise decision on Curtiss's part. The XBTC would earn the nickname Eggbeater, likely due to the somewhat unconventional, though not unheard of, contra-rotating propellers. As a disclaimer, I could not find any official documentation regarding the name, so I'm led to believe that this is merely an unofficial nickname given to the aircraft some years later. Although the R3350 had its first run in 1937, it was still a work in progress. It was not put through flight trials until the maiden flight of the Douglas XB-19 in June 1941. The promising engine was in high demand but low supply. In addition to the XB-19, it was also being used for the Martin XPB-2M Mars and the Boeing XPBB Sea Ranger. Later, the vast majority of the engine's production would be required for the Boeing B-29 Strategic Long-Range Bomber. As such, the XBTC-1 contract was terminated in late 1942, after only a single mock-up had been completed. Unfortunately, development of the XBTC-2 would proceed slowly as it was labeled low priority by the U.S. Navy. Curtiss was already suffering project delays with the SB-2C Helldiver while also working to develop the SC Seahawk, a new scout observation seaplane that was given a higher priority over the XBTC-2. Due to the low priority status, the first prototype, Bureau number 30401, would not fly until January 1945, just over 2 years after the prototype was ordered. In contrast, the Martin XBTM Mauler, which was ordered in May of 1944, and due to skepticism on Curtiss's ability to deliver, took its maiden flight in August 1945. The second XBTC prototype, Bureau number 30402, would not be available until 1946. Little documentation about the early phases of development have survived. The earliest photos of the mock-up stage, dated December 1942, show an XR4360-8A on what was presumably the former mock-up of the XBTC-1, as it lacks other modifications to properly accommodate the larger and heavier engine. Due to the extra weight, the tail surfaces required an increase in surface area. This would help control the extra engine power while also adding extra weight to counter the weight in the nose. Externally, the XBTC-2 appeared mostly conventional, except for the contra-rotating propellers. However, the wings were especially unique. 401 was fitted with a conventional straight wing referred to as Model A. The leading edge was perpendicular to the fuselage, while the trailing edge had a forward taper. The aileron spanned about 3/4 of the outer panel, with the remaining span taken up by a set of flaps. 402 was fitted with what was known as the Model B wing, or duplex wing. On this wing, the trailing edge was perpendicular to the fuselage, while the leading edge tapered rearward, giving it a slightly swept wing appearance. That's not where the differences end, however. On the Model B wing, the aileron extended full length of the outer panel, taking up approximately 2/3 of the wing. The flaps were located just ahead of the aileron, tucked in the bottom part of the outer wing. The contra-rotating propeller promised several advantages. Most notably, especially in the case of a carrier pilot, the design would counter the torque effect that plagued high-power, single-engine aircraft like the Ep.2 Corsair. The use of contra-rotating propellers also allowed the design to make the most of the 4360's significant power without the need for comically large propellers. This reduced the risk of a prop strike during the aggressive deceleration of an arrested landing. Of course, there is no free lunch in life, and the contra-rotating propellers, while offering benefits, did come with their own set of faults. Primarily, the extra set of blades added weight to the already heavy aircraft, along with a heavy and complex dual-rotating gearing. A series of vibration tests were conducted in May of 1945, and stress surveys revealed problems with the Curtiss electric propeller. This would soon be swapped out for an Aero Products model with a slightly smaller diameter of 13.5 feet. In terms of ordnance, the XBTC carried its primary bomb load in an internal bomb bay located in the fuselage. It could also make use of external wing-mounted racks to carry its secondary ordnance. Internally, it could carry up to a single 1,600-pound bomb. Other options included a variety of different bombs, a 650-pound depth charge, or a 1,000-pound aircraft mine. Externally, it could carry a 350-pound depth charge and up to a 1,000-pound bomb on each of the external racks. There was also provisions for carrying an externally mounted torpedo, however this would be mounted below the fuselage, preventing the use of the internal bomb bay. Offensive armament consisted of 4 wing-mounted 20mm cannons, with 200 rounds of ammunition per gun. These cannons were sighted so that they would converge at the center of the gun sight at a range of 400 yards. Curiously, some of the images of the mock-up reveal what appear to be 2 20mm cannons as well as 3 50 caliber machine guns on the wing. I cannot find any definitive information regarding this, but any smaller caliber guns were removed by the time the prototypes were constructed. When it comes to flight limitations, the XBTC demonstrated a maximum indicated airspeed of 391 knots at sea level and 239 knots at 25,000 feet. In terms of maneuvers, the XBTC was approved for loops, immelmans, vertical turns, and aileron rolls, with full aileron deflection permitted up to an airspeed of 310 knots. During maneuvers, there was a 2G limitation imposed during testing. This limitation was significantly less than the 7.5 Gs that was a standard limitation for BT-class aircraft, and as such, Curtiss likely would have been required to demonstrate the XBTC could handle the higher G loads if it were ever considered as an operational aircraft. The 2G limit was likely just to satisfy the experimental status of the aircraft. Flight testing would commence in January 1945, and the aircraft would run into a series of unfortunate accidents. In March, the XBTC was involved in a landing accident when the left main gear failed to lock in the down position, resulting in a collapse. Shortly after this accident, the aircraft was fitted with the aforementioned Aero Products propeller. The aircraft was briefly grounded when problems with the propeller drive gears arose. It is unclear how long the aircraft remained grounded, but it would be over a year before the next major accident arose. In March 1947, the second prototype, 402, was destroyed in a crash landing after an engine failure during stall tests. The cause of the engine failure was credited to a failure in the planetary pinion gear. Lieutenant Luis O'Neill of the Flight Test Division was at the controls during the accident and suffered a lacerated and fractured arm, but otherwise made it out with no life-threatening injuries. The first prototype, 401, would continue to fly through August before being transferred to the Naval Air Material Center in Philadelphia, where it was eventually scrapped. The Army Air Force briefly expressed interest in the project, even assigning the designation A40 to a proposed denavalized version. However, the Army Air Force later decided the project was redundant, as the Douglas Skyraider was more than capable. In the end, the XBTC was too little, too late. Curtiss's name had already been tarnished by the shortcomings of the Helldiver, and the XBTC was given such a low priority that by the time of its first flight, the need for such an aircraft was no more.